Hi everybody, in this video let's look at the new chapters. Chapter 7, Graph of Motions. This is Form 4 Monomath. In this chapter you are going to deal with a lot of graphs which involve motions. So these are the two types of graph that you are going to learn in these chapters. Distance against time graph and speed against time graph. Okay, so in this video we are going to focus on 7.1. Distance against time graph. Before I show you some example, let's look at this graph first. Now I have a graph, distance against time. It is very important when you are given a graph, right? Look carefully the y-axis and the x-axis. What are represented by the y-axis, x-axis, and also the unit here. So this is meter, this is second. What information can we get from this graph? Okay, now let's focus on this part first, this part OA. Okay, before that let me give some number for this graph. This is 5. Okay, how about this? Let it be 10, this let be 14. Okay, 14. Okay, let it be 10 here. So let's say the object start moving from the location A. Location A. From this graph, we know that the object is moving further and further from the location A. Within the first 5 seconds, the object already traveled for 10 meters. 5 seconds travel for 10 meters. So how do we calculate the speed? I hope that you still remember. We take the distance travel divided by the time taken, right? So the distance travel here is 10 meters. And the time taken here is 5 seconds. When we take 10 divided by 5, you get 2. It's very important, look carefully the unit. This is meter per second. So it means that the speed of these particles of this object within the first 5 seconds is 2 meters per second. So what we are calculating here is the gradient of this part. Okay. The coordinate for point A for this is 5, 10. How about this point? 0, 0. So if I want to find the gradient, right? OA, gradient of OA. y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. So this is 10 divided by 5, you will get 2 as well. So they are actually the same thing, right? 2 meters per second, this is 2. So if you write the units, you will also get 2 meters per second. So from here, we know that if you have a graph, distance against time, the gradient of the graph representing the speed of the object. But you have to be careful when you get a negative gradient. Okay, so now the object start to move further from the point A until here. You will notice that within this period, this part, the distance from the location A remain unchanged, right? What does this mean? It means that the particles, the object stop moving within this period. After that, this object move back, return back to location A, become closer and closer and closer to location A until it's back to location A. So just now I told you that when you have a graph, distance against time, the gradient representing the speed, right? Okay, but you have to be more careful when you have a negative gradient. So now let's try to find the gradient for BC. The coordinate here is 10, 10, The coordinate here is 14, 0. Okay, so if we want to find the gradient of BC, we know that the answer must be negative because this part is inclined downward, right? 10 minus 0, 10 minus 4. Okay, let me check the correct now. 10 minus 0, 10 minus 14, sorry. 10 minus 14. Okay, 10 minus 0, 10 minus 14. So this is 10, negative 4. So you should be able to get negative 2.5. Okay, but if the question asks us to find the speed within this period, we cannot give this as our answers. Because when we talk about speed, we always give our answer in positive. In the futures, when you learn about velocity, that can be negative because that's a vector. So speed, we always give our answer is positive. When you have gradient positive, the speed positive, right? Going away, going away. So AB here, the gradient is 0, means that stationary. So remember this word. Stationary means that the particles, the object doesn't move. Okay, here may be a little bit confused. I write negative here. When you get the gradient of BC is negative, right? When we talk about speed, I put a negative here, so I think better we change it positive so that you won't confuse. So speed, we always write positive. When you get negative gradient, when you find the gradient is negative, it just means that the particle is moving back to the starting point. Okay? So now I hope that you can understand this type of graph thoroughly. Okay, so now let's look at some example. Example number 1. A road of length 110 kilometer connects two places P and Q. So we have two places P and Q. Here is 110 kilometer. Starting at a distance of 10 kilometers from point P, it means that when the object starts to move, its distance from the location P is already 10 kilometers. Means that the object is not starting to move from here, but from here, somewhere around here. So this is a starting point. And the distance here is 10 kilometers. A tractor travels along the road toward Q. Okay, the tractor starts to move from here, 10 kilometers from P. The distance of the tractor in the durations of 5 hours is shown in the table below. So now I have a table here. We need to draw the distance times graph. I think this one you should be no problem, right? Okay, let's take a try. Pause the video, try to draw the graph. Because of the question tell you that when the tractor starts to move, it's already 10 kilometers from P. That's why you look at here. When the times is 0 hours, the distance from point P is 10. So this information we can get it from here. Okay, so now let's start to draw this graph. Okay, so now I have drawn the axis here. So the next thing is to label the axis. So we have been given a small grid here. We need to use this grid paper to draw a graph. So we try to plan our scale, draw the graph as big as we can. So this is distance from P kilometer, and this is time, hours. So the distance here, the maximum is 110, the minimum is 10, so we start from 0. So 10, 20. So I don't want to make it too crowded. I label 20, 40, 60 like this. So 20, 40, 60, and this is 80, 100. Okay, I think I better label it because here I want you to see 110. So this is 10. Okay, so we have finished label the y-axis, vertical axis. Now we go to horizontal axis, time. So we have 5 hours here. 1, 2, 3, 4, and 5. So the next thing is to plot the point. When the time is 0 hours, this is initial time 0, and the distance from point P is 10. So it will be here. Make a mark here. Plot the point here. When the time is 1, the distance from point P becomes 30. 30 is over here. Okay. When the time is 2, the distance from point P is 50. 2. 50 is over here. And when the time is 3, the distance from point P is 70. 3, 70 is over here. Okay, so after you have finished plotting all the points, what we need to do is just connect all these points together. Okay, so this is a graph. So from here you get a perfect straight line. So from here you know that this tractor move in a uniform speed. Uniform speed means that the speed of the object always remain unchanged, always the same. Okay, so you can find the gradient between these 2 points, this 2 points, or this 2 points. You always get the same. It means that this object, this tractor move using a uniform speed. You have a straight line. If let's say you have a graph, this is distance, meter, this is time. Okay, let be second. The distance times graph look like this. So from here we know that that object is not moving using a uniform speed. From here it's faster, and here becomes slower. The speed change. Okay, so this one I think you learned before in Form 2, right? Then you should be okay, right? Uniform speed means that constant speed. The speed of that object always the same. Okay, so let's try the next example. An express train is traveling from station M to station N. After T minutes, the distance as kilometers of the trains from N is given by this equation. Now we have equations. We need to use this equation to help us to get the value of S. Complete the following tables and draw the graph of S against T. Means that we are going to draw a distance against time graph. Okay, how do we get all this value? Is actually this, very easy. S is equal to 300, this is given by the questions, minus 5 over 2t. So when t is equal to 0, S is equal to 300 minus 5 over 2 times t. T is equal to 0, S is equal to 300. So here we just fill in the table here, 300. So how about when t is equal to 20, we do exactly the same thing. You can actually use your calculator to help you to get all the value here. So how do we get is actually the same thing. You just plug in the 20 over here, then use a calculator to help you to get the value. When this t is equal to 40, plug in the 40 over here and use a calculator to help you to get the value. Okay, so we have complete the table. The next thing is to plan where to draw our x-axis, our vertical axis and horizontal axis. Okay, so I have drawn the vertical axis and x-axis, vertical axis and horizontal axis. The next thing is to plot all the point here. 0, 300. 0, 300 is over here. 20, 250. 20, 250 is over here. 40, 200. 40, 200. 60, 150. 80, 100. 150, 100 here 50, and the last one is 1200, 1200. So the next thing is just to connect all these points together. Okay, so this is a graph. Now let's go back to these questions. An express train is traveling from station M to station N, right? So after t minutes, the distance as kilometer of the train from N is given by this equation. So the question tells us that it's traveling from M to N. It's actually getting closer and closer to N, right? So from here we know here is actually station M, and this is station N. So when the train just want to start to move, it's actually 300 kilometers from station N. So after 20 minutes, the trains become closer to station N because it's moved towards station N. Now after 20 minutes, it is 250 kilometers from station N. So after 40 minutes, the train get even closer to the station N. Now it is 200 kilometers from station N. So after 120 minutes, 120 minutes, you will notice that it is 0 kilometer from station N. It means that it already reached the station N. Okay, I hope that you can understand this graph well. Okay, so let's proceed to the next example. Okay, let's look at this example. The distance time graph shows a journey of a car from town P to town Q. So I will encourage you to write this thing, town P to town Q, into the graph, so easier for you to answer the questions. Town P to town Q, and back to town N. So this is town P. So I think I just label P over here. P, and this is Q, and here's N. From town P to town Q, and then rest there, and then back to town N after passing through the town P. Okay, so the question also tell you back to town N after passing through town P. Okay, now let's go to see what are the questions. Calculate the distance between town N and town P. Town N and town P. So you see, if you label all this information onto your graph, then it will be easier for you to get the answers. From town P to town N, which is here and here. How many kilometers? 10 kilometers, right? So the answer for this part is 10 kilometers. Okay, let's go to part 2. Tau P and tau Q. P and Q. What's the distance here? 35 minus 10, which will give you 25. Okay, now let's proceed to the next part. Q and N. How many kilometers here? 35 kilometers. From here, this is 0. And here, 35, right? 35 kilometers. Calculate the durations in minutes. So this is minutes, this is kilometer. The durations in minutes for the journey from tau P to tau Q. From tau P to tau Q, which is here. How many minutes? 20 minutes, right? 20 minutes here. From tau P to tau Q. This is 20 minutes. Okay, how about this? During which the car stopped at tau Q. Here, stationary stop. The car rests at tau Q, doesn't move. How many minutes? Take 65 minus 20. 65 minus 20, you will get 45. Okay, so in the exam, right, you cannot just give your answer like this. You have to show your step clearly. So durations, for example, B2, right? B2 duration. You have to show your calculation clearly. So take 65 minus 20. You get 45 minutes. Okay, so this is the way how we get the answers. So for the journey from Q to N, Q to N is over here. So what's the durations of the time? So same thing, you have to show your calculation clearly. You have to take show like this, 80 minus 65. You will get 15 minutes. Okay, let's proceed to part C. Find and interpret the gradient of the graph. We need to find the gradient of the graph for AB, BC, and CD, and then we need to explain what can we get from that information. Okay, AB. Okay, I think let me erase this one first. What is the coordinate of B? 20, 35. 20, 35. And this is 0, 10. And this point, 80, 0. Okay, now we have all the coordinate. We can start to calculate. Okay, how about this one? 65, 35. Okay, let's find the gradient of AB first. Okay, I think I erase this part first because if I write over here, you cannot see the graph. So it's better I write somewhere around here. C part 1. Gradient of AB. So still remember the formula? I hope that you still remember y2 minus y1 divided by x2 minus x1. Now we have to focus here, AB. 35 minus 10, 20 minus 0. So here you will get 25. This is 20. Okay, just press your calculator. You will get 1.25. So you look at the unit here. This is kilometer, this is minutes. Then you know that this is kilometer per minute, right? Okay, what informations can we get from this? From here, we know that the car, this is car, right? Car or lorry. This is a car. The car travel from town P. So this is AB. AB is over here. Town P to town Q. Town P to town P to town Q with a speed of 1.25 kilometer per minute. Okay, so this speed means that every minute the car travel 1.25 kilometer. Okay, so we do the same thing for BC and CD. Okay, I forgot to write the car here. The car travel, okay, here the car travel from town P to town Q with a speed of 1.25 kilometers per minute. Okay, let me erase this one. Try part B. Part C, second part. Okay, so now we have to focus here. So this is 0, right? When you look at the line, you know that if you want to find the gradient is 0. So the gradient, okay, this is part C. Part 2. Gradient for BC is equal to 0. So it means that the car is rest, or if you don't want to use the word rest, you can use stationary. Okay, this word remember because you will always see these words in these chapters. Means that within this period the car doesn't move, rest at town Q. Okay, we try last one, last part for part C. CD, gradient for CD. So now we need to focus on this part. CD. Same thing, we use a gradient formula. Y2 minus Y1 over X2 minus X1. So this is minus 15. Let me check correct or not. Okay, correct. So 35 divided by negative 15. Okay, I change it become a fraction. You will get, oops, sorry. You will get negative 2 and 1 over 3. So remember, when we write the speed, don't give negative. So we get the gradient negative. This is kilometer per minute, right? So it just means that the car is returning back. When we give the speed, right, we need to give our answer is positive. So the car travel from town Q to town N with a speed of okay, don't write the negative. 2 and 1 over 3 kilometer per minute. So if you don't want to use this answer, you can give your answer in decimal 2.33. Okay, now let's try the last part. Calculate the average speed in kilometer per hours. Okay, be careful. This is per hours. And this is minutes. Calculate the average speed in kilometer per hours of the car for the whole journey. So what is the formula for average speed? Average speed is equal to total distance travel divided by the total time taken. Right? Okay, so the total distance travel for the whole journey. So you have to be careful. You cannot just take 35 from P to Q. Here is P to Q 25 and then go back. This is 35. So the total distance travel will be 25 plus 35. And this is kilometer. Okay, so for the whole journey, the car used 80 minutes. But the question is asking you to give your answer in kilometer per hours, no 1 minute. So 80 minutes here, we have to change it become hours. So how do we change 80 become hours? 80 minutes become hours. I think this one you should be no problem, divided by 60. Now this become hours. So you will get your answer in kilometer per hours. So this is 70, right? Sorry, 60. Okay, so this 80 divided by 60, 4/3. Okay, so here you just use a calculator to help you get the answers. 45 kilometers per hour. Okay, if you don't want to give this way, you can also give your answer in this way. These two are the same thing, but if you write this way, this is not correct. Okay, if you put a slash here, you don't have to put a -1. If you don't want to put a slash here, you have to put -1. Okay, so in this video I just stop here first because I think this video is already quite long. I will continue the next next few example in the next video. Thanks for watching. See you in the next video. Bye bye.